Welcome to week 6. By now, most of you should start getting pretty comfortable with the Oracle database environment, but it's understandable to have questions in areas where you may not feel absolutely confident in this new environment. As we noted at the beginning of this course, remember this is a foundational course where everyone came to this class with a different level of experience. By now, you've probably identified your go-to people or your in-class experts, and these people are important in helping you become a stronger database administrator. If you've ever read the book Outliers by Malcolm Gladwell, then you'll be familiar with the concept of 10,000 hours. His research demonstrates that to develop true expertise, one must invest about 10,000 hours, which is somewhere about 10 to 15 years in the practice. While most of us couldn't imagine 10,000 hours of databases, there are those few that fall in love with this environment and dedicate their entire professions to becoming the best database administrators in the world. Truly, this is a career field that offers many lucrative opportunities. But, as every expert will confirm, everything rests on the foundational concepts of a given discipline. This week, we look at a multitude of different functions ranging from the basic to some of the more advanced as we round out these foundational concepts in this review. Let's start with single row functions. The objectives in this discussion will be to use the upper, lower, and init cap functions to change the case of field values and character strings. We'll manipulate the character substrings with a substring and an inster function. We'll nest functions. We'll explore the length function as well as the lpad and rpad functions. We also will look at a ltrim and a right-trim function. Then we'll substitute a character string with the replace and translate functions. Adding to this, we'll round and truncate number data using the round and trunc functions. We're going to use the mod function, the ABS or abs, to set numeric values as positive or absolute. We'll use the power function to manipulate data. And finally, we'll perform condition processing similar to the if statements using a decode function. Now let's get started. Let's define some terminology. By now you've heard me mention functions a few times now, but there's really 3 core definitions that I think that we should put on the table. Let's define the function, a single row function, and then a multi-row function. You see, a function is a predefined block of code that accepts arguments. A single row function returns 1 row of results for each word processed. A multi-row function then returns 1 result per group of data processed. Next, we're going to explore many functions this week, most of which are captured here in this chart. Notice that we classify these function types into about 6 unique categories. I'm going to give you a moment to digest and just review this, as it's really going to kind of lay a foundation for what we're about to discuss. Notice the upper, lower, and init cap when we discuss case conversion functions. And when we talk about the other functions later in this coverage, you'll see that we talk about the NVL, NVL2, and decode, for example. Also note the difference between character manipulation functions like concat, which we've discussed in prior discussions, and the LPAD or RPAD versus the date functions, where we look at, say, concurrent date, for example, or we round or use truncation. Okay, let's get started. Let's look first at character manipulation functions. The sub-str function is really used to return the substring. Here you see how we use the select statement to set this up. We're going to say select a distinct from where. CR where, then we enter the substring. We want to have the zip, and then our numerical variables. Notice then the results, how they reflect what we returned here. You may find that a substring is particularly useful when working with data values that may be organized by some kind of coding scheme. Maybe it's an employee benefit, or ledger accounts, or inventory IDs. This is one area that I would generally use substrings. Two arguments must be provided in the instr function: the string value to search and the characters or substring to locate. Next, let's talk about the idea of nesting. There's no birds here. Nesting simply means using one function as an argument inside another function. Take a look at this graphic and see how one argument is nested within the other function. This graphic really demonstrates how to nest functions in a select clause to extract the first name from the name field. Now what if you want to limit the number of characters that can be in a string? This example shows how we can use a length function to limit or otherwise assign how many characters can be in a string. Now I know paper checks are quickly becoming a thing of the past in an age of direct deposit. However, here we get to the LPAD and RPAD functions. If you work for a large company, you may have received a paper paycheck at some point that had the dollar amount preceded by a bunch of asterisks. This is because many companies use symbols to fill in blank spaces on their checks. The LPAD or RPAD function can be used to fill in such spaces, to the left or right respectively, with a specified character. For example, if you prefer to use the @ symbol instead of an asterisk in such a case, now you know you can make that change directly in the database. The LTrim and RTrim, or left trim and right trim functions, are used in a similar fashion as the left pad and right pad. Only here, the left trim and right trim, we're cutting out, not filling in. The book uses the example of cutting out a word P.O. box from a customer information. The idea then is that the word P.O. box would not be duplicated in records. What about the replace function? Here we get to look at this replace function, which depending on your database environment can really be a neat tool for you. Using again the P.O. box example, where the word post office box can be replaced with a P.O. box. If you've ever logged into a database to see your username show up as something like Mr. Wimpy, then you too see the ways that database administrators like to enjoy the replace function in their inter-office jokes and pranks. Perhaps the truth is, the geek you picked on in high school will really get the last laugh, especially if he or she is your database administrator. Let's move on to the translate function. Similar to a replace in some ways, the translate function is used to replace a character in a string with a new value. This is often used in example to notate names properly, especially when names have more than one capital letter. A name like McDonald or Le Fondant, as seen here. Now let's return back to concatenation. Here we see how to use the concat, short for concatenation, which we know in this course to mean combine, to in fact combine data from two columns. The round function is quite literally used to round numbers up or down to your specification. Continuing on with numeric values, let's look at the truncate. Here, we use truncate in a numeric value for a specific position. With this discussion of numeric values, let's take a look now at date values. By default, Oracle displays date values in the following order: day, month, and year. For those who may have served in the military, well, you'll know that that's not always how it's done. A DBA can adjust the date format in the configuration files of the database. Interestingly, Oracle supports date ranges that go from January 1st, 4712 BC to December 31st, 9999 AD. Date functions are really important when you consider performing date calculations or to format date values. You see here in this example, sometimes we'll subtract a date to get a number of days difference. Keeping the date values discussion going, this is a format argument model. Here you see how the different elements are presented in Oracle. Notice how the month element is provided in the example as April. Alternatively, there's a three-letter abbreviation for the name of the month, which can be MON, in which case the return would be APR for April as above. Likewise, it can be returned digitally in numeric values. Here you see the MM then would be used for an 04. And then the same is true if you move further into the days and the years. You see these correlations. I'm going to give you a moment to check out this chart here because it's a little text intensive. What I want you to at least call your attention to, however, is the very bottom, the BC or AD, which is the value indicating whether it's BC or AD on a timeline horizon. Remember, Oracle supports date ranges that go from January 1st, 4712 BC to December 31st, 9999 AD. In the beginning of our discussion today, we talked about those infamous other functions. Here we start with the NVL function, which can be used to address problems caused when performing arithmetic operations with fields that may contain null values. Something important to remember here is that when a null value is used in a calculation, the result is always a null value. Next up in this other category is the NVL2, which is actually more preferred by database administrators versus the NVL, simply because the added flexibility that it provides when working with null values. Here we've come to the null-if function. We use this little gem to compare two values for equality. Basically, if two values are equal, this function returns a null value. Tochar can be a slippery function, and I say this only because one must first appreciate that tochar is the opposite of toDate. Let me say that again. Tochar is the opposite of the toDate function. In Oracle, tochar is primarily used to display dates in a particular order format. Much like a military date format, which would be year, month, day, as opposed to day, month, year. And this is what I was referring to earlier with the military reference. Here is a chart that demonstrates time in number elements. When looking at the elements here, now that I've given you a time to look at this chart, I'm going to draw your eyes down to the period and the comma, or the decimal and the comma. Primarily because the decimal here indicates the number of decimals to display. Likewise, the comma displays comma in the position that is indicated. This is important when working with financial figures. The decode function actually offers a handy match feature, as it takes a specified value and compares it to values in a list. If a match is found, the specified result is returned. If no match is found, the default result is found. If there is no specified there is no specified default, a null will be returned. Notice here in the examples again point to the opportunity to use this with financials. Here, the tax or sales tax rate is really the financial that we're going after with this decode. Let's look at another similar feature in case. Case expression. This is very similar to the match function of the decode, except this only allows it to a greater functionality, such as including date ranges. Now we've introduced a lot of fairly dense information here, so understandably you may want to rewatch this to get a better idea of some of these functions and gain a little bit more familiarity with them, especially if this is the first time that you're seeing some of these. The reality is, you probably won't use some of these functions, maybe perhaps ever, but the important thing to know is where to look when you need them. For now, let's summarize what we did cover here. Single-row functions will return a result for each row or record processed. Case conversion functions like upper, lower, and init cap can be used to alter the case of a string of characters. Character manipulation functions can be used to extract substrings, portions of a string, identify the position of a substring in a string, replace occurrences of a string with another string, and determine the length of a character string, and trim spaces or characters from strings. Nesting one function within another allows multiple operations to be performed on the data. Simple number functions such as round and truncate can round or truncate a number on both the left and the right side of a decimal. The mod function can be used to return the remainder of a division operation. Date functions can be used to perform calculations. The MVL, MVL2, and null-if functions are used to address problems encountered with null values. The toChar function allows a user to present a numeric data and dates in a specified format. Decode, alternatively, allows an action to be taken to be determined by a specific value. Similarly, the case expression enables you to evaluate conditions to determine the resulting value. A dual table can be helpful when testing functions.